So the big thing that helped me, and I feel like maybe we already talked about this, but maybe I'm thinking of last semester, is the rotational stuff and the kinetic stuff is super similar. It's like the same. We just have new variables for our velocity and our distance and our acceleration. Have we talked about this? So like at the beginning of the semester, we had all these kinematic equations. Like for example, we had x equals x naught plus v naught t plus 1/2 a t squared.
Yes.
And so you guys are probably pretty comfortable with that equation because we've been seeing it here and there all semester long. Now we've got rotational stuff, and this equation still totally works, but now we have to, because before we had like a flat type of thing going on where we said, okay, here's x equals 0, here's x equals 10 meters or whatever, and then we had some sort of linear speed and some sort of linear acceleration. But now, so now we need to take that logic and we just need to wrap it into a circle. So we're just like taking this straight stretch of ground or air or whatever this linear space is, and we're just wrapping it around a circle. And now all circles are the same because it's the same shape. The only thing that differs one circle from another circle is the radius. So these two circles are identical. Well, they should be identical if I drew them right. In every way other than one might be bigger or smaller. And the way we measure that is by how big the radius is of that circle. So all we're doing is we're taking this straight piece of space and we're wrapping it around a circle with some given radius. So all we're going to do is we're going to go through and we're going to divide all these variables by the radius of whatever circle we're wrapping them around. And so if we do that, we could just write it like this and it would be fine. But that looks messy, so what they did was they said, okay, x divided by r is really just theta. And then they said, and so x naught divided by r is just theta naught. V divided by r is omega. And a divided by r is alpha. And so instead of writing the equation like this, we write it theta equals theta naught plus omega naught t plus 1/2 alpha t squared. So we don't divide time by radius, and that makes sense because time is still time whether we're doing linear stuff or rotational stuff. And so that same logic applies to all of our other kinematic equations as well. Like we had this guy which said v equals v naught plus at. So we divide the stuff by r, and that turns into omega equals omega naught plus alpha t. And then we had this other equation that said v squared equals v naught squared plus 2a times change in x. So we divide all those things by r, and that just turns into omega squared equals omega naught squared plus 2 alpha times change in angle, theta. So it's really the same stuff. All we're doing is we're taking what used to be flat and we're wrapping it around a circle. Does that make sense? And then, so knowing this becomes useful as well. So if we memorize these, which should be pretty easy, because we probably already have these, close to memorized, if not memorized, from the beginning of the semester. And so all we need to do is remember the same exact form. We'll just swap out the thetas and the omegas and the alphas in the appropriate spots. So memorizing these should be pretty easy, given that foundation. And then if we memorize these relationships, then we're pretty good to go for a lot of things. That's like a really good foundation for rotational physics. And there's some other things that we'll have to deal with, but if we get that stuff down, then we should be pretty well on our way. Does that make sense?
Yeah.
Cool. So that's kind of crash course. Now let's put it to use with some questions, hopefully.
Yes.
This is the kind of review that you were
Yeah.
wanting to
Yeah.
talk about. Is that
'Cause, yeah,
helpful?
the whole like.
I couldn't figure out how they were getting like the Greek letters from like the X naught,
Mhm.
stuff.
Yeah, it's because of this relationship. Cool. So erase all that. And then of course there's other things like centripetal acceleration that you guys have already learned
Yeah.
about, right?
Yes,
Mhm.
you have.
And so that's an equation that you'll see a lot, which is
So what's the difference between that and like an angular acceleration?
an angular acceleration.
Yeah.
When you say angular acceleration, you're talking about alpha.
Yeah.
So
There's like a whole equation. Well, I guess it's just what we just talked about.
yeah, so yeah, that actually is a good question. I don't like this marker. So when we have so here's a little bit more just conceptual review. If we've got a circle and we've got an object traveling the path of that circle, so here's our object. It's going round and round. If we want that object to just go around the circle and maintain its constant velocity, then all we need is some centripetal acceleration pointing directly in towards the circle. And the reason that we need that centripetal acceleration is to keep it turning. Because if we didn't have some force pushing it in, then it would just shoot off in some linear direction. But we need a constant force pushing in towards the center to make it turn, constantly. So it's always in a turning state. If we want it to go around the circle and speed up, then we need a force pointing in to make it turn and a force pointing, forward to make it go faster. And so if we combine those two forces, then we'd expect to see some sort of acceleration like that, pointing in and forward. If we want it to go around the circle and slow down, just the opposite. We need an inward component and a backwards component. So that way it's continuing to turn, but it's also slowing down and eventually will come to a stop. So the inward component is always centripetal acceleration, which is v squared over r. And then the forward or the backward component, that's usually we call that tangential acceleration. So I want to say the tangential acceleration is alpha. But I've never thought about that, so I don't know if that's completely true.
It says that it's R alpha.
It says R alpha.
Yeah.
What do you mean?
Well, I don't know. I just have that.
Oh, maybe the radius times alpha. Yeah, I think that's what it's saying. So that goes back to this idea where before we said if we take our normal A that we're used to from the beginning of the semester and we divide it by R, then that equals alpha. So all they're doing is they're just rearranging it and saying
Okay.
A equals alpha times R. They're just multiplying that R over. Yeah, so that's kind of weird, but those are the different accelerations we have going on.